Suppose the supply and demand for carrots are given by the following two equations, where T is time, a proxy for evolving taste over time, W is weather, Q is quantity supplied and demanded, and P is price, which is endogenous in the model. The reduced form equation is found by solving the system of equations for P as follows. We have the demand equation on the left and the supply on the right. We put the two expressions containing P on the left and the two error terms on the right. Then we factor the left and divide by the difference of parameters 1 and 4. The reason why P is endogenous is because it is not only correlated with T and W, but also the error terms. Two-stage least squares is a trick that makes endogenous P exogenous because its first step estimates equation 1 using OLS. Notice that P hat, not P, but P hat, is only correlated with W and T. P hat is not correlated with the error terms. Equation 2 is referred to as a reduced form equation. Notice it does not contain Q. W and T are instruments, while P hat, W, and T are the instrumental variables. The first step in two-stage least squares and three-stage least squares is to estimate equation 2 using OLS. The OLS estimate of the vector parameters is equal to the inverse of x transpose x times x transpose y, where y is the set of all prices and x is a column of 1's and W and T's observations. Excel has several matrix commands, which are easier to use if the variables are named first. In Excel, you can name a set of observations by clicking first on the number, for example 10.03, holding on the Shift key, and then hit the arrow down key until all numbers are highlighted. Then right-click on the highlighted observations and then choose Name a Range. Again, this is the vector y. Do the same thing for the constant, W and T. We're going to name this X. Now to compute the reduced form OLS estimates for P hat, click on cell 32, right below the A0. Hold down the Shift button and press the right arrow key twice. This is necessary because the result of the linear algebra in equation 3 is a set of 3 numbers. Now type, which I've already typed for brevity, type equal transpose open parenthesis M multiply. M multiply stands for matrix multiply. Then open parentheses again, M inverse. M inverse is matrix inverse. Open parentheses. Matrix multiply, M multiply. Open parentheses. Transpose X, comma, X. Close parentheses twice. Then type M multiply, open parentheses, transpose, open parentheses, X, comma, Y, and then close the parentheses 3 times. And then hit the Shift Control button simultaneously, hold down, and then hit Enter. This is the constant in equation 2, and this is the slope of the weather indice, and this is the slope coefficient for the proxy for taste over time for carrots. So these are the reduced form estimated parameters. Next, we want to compute P hat. And to compute p hat, we're going to rely on the sum product function in Excel. So you type equal sum product, open parenthesis. I'm going to highlight this array, but I'm going to put dollar signs between the C and 32 to hold them constant. And then I'm going to hit a comma, and I'm going to highlight this first row of observations. Now I use the dollar sign because I'm going to copy and paste this cell to these cells. And the dollar sign holds, again, this row constant. So for example, if I pull this down, do a copy and paste, the green row has fallen one, but the blue row is frozen. That's why I use the dollar sign. So the predicted values of the price are given here. P hat, W, and T are what we call the instrumental variables. Next, we put the variables in block diagonal form. Note, this is not necessary for two-stage least squares, but is for three-stage least squares. Since the matrix of independent variables was denoted X in the first step, I will denote them in block diagonal form as Z for three-stage least squares. Here we have Q, quantity demanded, and then we have the same exact numbers as quantity supplied. So this first double stacking of the price variable is what I call stacked Y. We stack Q on top of Q. Then we have the first equation. The first equation involves these rows and cells. Notice we have a bunch of zeros over here, and we have the price, the original price, not P hat, temperature, and the constant. Down here for the supply curve, we have a block of zeros here, and then again we have the price, not P hat, weather, and the constant. So this form is what we call block diagonal form. We have a block of zeros, we have another block of zeros, and then we have the variables for the demand curve and the variables for the supply curve. Now if we perform OLS with blocked Y and blocked X, also known as Z, we would estimate the SIR parameters. Now remember, we didn't want to use the price, we wanted to use P hat, because price is correlated with error terms. P hat wasn't. So the difference between this part of the new block matrix and its counterpart in the old block matrix is the fact we've replaced the price with P hat. The other parts of this block matrix are the same. That's the same thing that we do in the second part of the block matrix. We simply replace P with P hat. Now we're calling this block matrix Z hat because it includes the instrumental variables P hat, T, and W. The difference between two-stage least squares and three-stage least squares is this. In two-stage least squares, we take the quantities and regress that on P hat, T, and the constant to give us the two-stage least squares estimates for the demand curve. To get the two-stage least squares estimates for the supply curve, we do the same thing. We take and regress the quantities on P hat, the weather index, and the constant term. That yields us a separate set of estimates the two-stage least squares estimates for the supply curve. With three-stage least squares, we regress the stacked quantities onto the blocked z-hat matrix. And the result gives us the three-stage least squares estimates. The second stage of three-stage least squares involves estimating two-stage least squares estimates, which means we have to ignore three partitions of z-hat, this part of z-hat, this part of z-hat, this part of z-hat, and one part of the stacked y down here. Now, the two-stage least squares estimates, which we're going to put right here, here, and here, are found by applying OLS to this part of stacked y and this part of z-hat. Before we do that, we're going to name this part of y, we're going to name it y1 underscore. And then we're going to hit OK. We're going to name this part of z-hat z1 hat. Now we just apply OLS to y1 underscore and z1 underscore hat. And the way we do that is we just type, like we did before, equal transpose m multiply parentheses m inverse parentheses m multiply parentheses transpose parentheses z1 hat close parentheses z1 hat close parentheses m multiply parentheses transpose z1 hat comma y1 underscore close parentheses 3 times. We hit Control Shift Enter and we get the two-stage least squares estimates for the demand equation. This right here is the constant. This is the coefficient, estimated coefficient for the time or taste preference variable, and this is the coefficient for the price variable, in this case price, the predicted price. And notice that the law of demand holds here. We have a negative 545.78.